Hello, in this video we will learn about data preparation phase to model the data. These are the topic we will cover in this video. So, what is data preparation? Data preparation is a critical step in the data science workflow that involves cleaning, transforming, and organizing raw data into a format suitable for analysis and modeling. High quality data is essential for generating accurate insights and building reliable models. Data preparation ensures the data is consistent, accurate, and ready for further exploration or analysis. Key steps in data preparation: first, data collection; second, data cleaning; third, data transformation; fourth, feature engineering; fifth, data integration; sixth, outlier detection; seventh, data reduction. Partition the data. Partitioning the data refers to dividing a dataset into distinct subsets for specific purpose, typically in the context of machine learning or statistical analysis. This step ensures that models are trained, validated, and tested on separate portions of the data to provide overfitting and assess their generality. How to partition the data? Step 1: import necessary libraries, load a data set, split the data, check the shapes. Now we will see how to partition the data set. First, so you can see we have imported necessary libraries over here. Then we will load sample data set. Here we have taken iris as sample data. Then we will split data into training and test data set. Further, we will split the training set into training and validation sets. Then we will print the shapes of the resulting data sets. You can see the output over here. Now moving towards the next topic, that is balance the training data set. Balancing the training dataset refers to the process of addressing class imbalances in the data, particularly in classification tasks. In many real-world datasets, some classes may have significantly more examples than others, which can lead to biased model prediction. A model trained on imbalanced data might favor the majority class and perform poorly on the minority class, leading to skewed results and reduced predictive performance for certain groups. Balancing the dataset aims to either reduce the size of the majority class or increase the size of the minority class to ensure that the model has an equal or proportional representation of each class. How to balance the training dataset using Python. Balancing the training dataset is crucial in machine learning, especially when you have imbalanced classes. This can lead to a model that favors the majority class, neglecting the minority class. Balancing techniques such as oversampling, undersampling, or adjusting class weight can address this issue. How to balance the training dataset using Python? We will see. As you can see, we have imported necessary libraries. Then we have created imbalanced dataset using mixed classification. We will display original class distribution. Then we will split data into training and testing set. After this, we will display the class distribution in the training set. Here we have done oversampling, then random undersampling, and then class weight adjustment in classifier. And after this, you can see the output over here. Now we will see how to build a cart decision tree. Cart classification and regression trees is a popular algorithm for building decision trees, which are used for both classification and regression tasks. The cart algorithm recursively partitions the data into subsets based on features values, creating a tree-like structure where each node represents a decision based on a feature, and each leaf node represent a class label for classification or predicted value for regression. Steps in building a card decision tree. Choose a feature and split the data. At each node, the algorithm chooses a feature and threshold value that best splits the data into two groups based on impurity reduction or variance reduction. Then we will repeat the process recursively. This process continues recursively until a stopping criteria is met. Example, maximum tree depth, minimum sample per leaf, the node reaches pure class distribution for classification, or the variance in minimized for regression. Prune the tree, optional. After it is optional, you can apply it or not. After the tree is fully grown, it may be pruned to avoid overfitting by removing branches that don't significantly improve the model. Now we will see how to build a card decision tree using Python. These are the steps. First we will do data preparation, then model training, then evaluation, then visualization. Now we will see the code. Here you can see we have imported important libraries over here. We have taken a dataset iris, then we are splitting the data into training and testing set. Then we will build a decision tree classifier, and we will make a prediction on the data test set. Then we will evaluate the model performance, which will define the accuracy of the model. Then we will plot the decision tree. As you can see over here, our decision tree in the output. We can also build it by using regression method also. Now we will learn about random forest. What is random forest? Random forest is a popular ensemble learning method used for classification and regression tasks. It operates by constructing multiple decision trees during training and aggregating their outputs either by majority voting for a classification or averaging for regression. This approach enhances the model's accuracy and reduces overfitting compared to individual decision trees. Application of random forest: medical diagnosis, finance, marketing, natural language processing. Now we will see random forest code. As you can see over here, we have imported important libraries. Then we have loaded the data set. Then we will split the data into training and testing set. After this, we will create and train the random forest classifier. Then we will make prediction on the test set. After this, we will evaluate the model's performance. And now you can see the output over here, and this can also be generated by using the regression method on the random forest, like random forest for regression method also available. So this is all for the video. Thank you for watching.